So after applying the sample in TLC plates, we have to air dry them to remove the mobile phase which was used to prepare the sample. We have to air dry it. We have to make sure that drying is done at a very lowest temperature, normally at room conditions, because if it is heated then the samples will be destroyed. And the development will be done with the help of development chambers. There are several methods available. First one is normal development, where only a beaker is used. Various sizes of glass beakers or jars are used for developing our TLC plates, but the disadvantage of this method is we have to use a large amount of solvent system, that is mobile phase, for preparing even one plates. And the next to that you can see it consists of a hump, so it is called as a twin trough chamber. So this with the help of this twin trough chamber we can simultaneously develop two plates within the same chamber, as it consists of a hump. It can be used to separate the two compartments, and also it is used to reduce the solvents we need for analyzing or separating our compounds. Then we can see so we have developed using a suitable development technique, and now we are going to detect or visualize our samples, because the developed spots can be sometimes colorless. If it is a colored spot, we can visually see and mark it with the help of naked eye, and if it is not a colored one, then we can use some specific methods. So specific methods means these methods can be used to detect some specific compounds, which means that they are used only for a particular type of compound, that is called as a specific method. So for example, ferric chloride is used for phenolics. In order to identify phenol and phenol related compounds, you can use ferric chloride. It will give you some colored compound as a result of the reaction. Then you can identify the presence of phenol. And ninhydrin for amino acids. So ninhydrin and amino acid will react to give a purple spot. So you can easily identify the presence of amino acids by using a ninhydrin solution. And the Dragon-Dorf reagent is used for alkaloids. And also 2,4-dinitrophenol is used for aldehydes and ketones. Also 3,5 dibenzoic acid is used for analyzing cardiac glycosides. So likewise, some specific reagents for specific compounds can be used to analyze or visualize the spots, and also some non-specific methods are also available. So what is the purpose of this non-specific spot is we can identify that a spot is developed, but we cannot say what type of compound it is. So for example, iodine chamber method. So in iodine chamber, we can analyze that some unsaturated compound is present in the spot, but we cannot say what type of compound it is. So if in iodine chamber we have to use sublime iodine. So this sublime iodine will be kept inside a beaker or jar, and you have to keep the developed TLC plate inside it, and you have to close it. So as time passes, the iodine balls will sublime. So all the solid iodine will be converted into vaporized ones, and these will go and settle or absorbed onto the surface of developed spots. So you can see the brown spots on the developed spots. Then sulfuric acid spray. So the sulfuric acid spray is used for all kind of organic compounds. The sulfuric acid along with some oxidizing agent like potassium permanganate or potassium dichromate will char the organic compounds. So that charring will give black colored spots. So with the help of 70 to 80% W by V solution of sulfuric acid along with the oxidizing agent, you can identify the presence of organic compounds. Then we can also use some fluorescent stationary phase. While preparing the TLC plates, we are going to mix the fluorescent stationary phase. So what will happen is in the fluorescent background you will be seeing non-fluorescent spot if you keep that slide in the UV chamber. And also directly in the UV chamber you can see the dark spots. Then the analysis of what are the applications of TLC are qualitative and quantitative analysis. In qualitative aspect we can find out whether the compound is present in the mixture or not with the help of these formulas, that is retardation factor, relative retardation factor and migration ratio. So with the help of these values we can easily say and compare our sample with the reference or standard and find out whether if it is present in our mixture or not. And in quantitatively we can do direct and indirect analysis, and we can say how much amount is present in the spot. By using a direct method like a densitometer, we can analyze the concentration of the developed spot in the same stationary phase, that is the developed environment. But in the indirect method you have to scrap that developed spot and you have to prepare that as a separate solution, and you can analyze it with the help of UV chamber or flame photometer or fluorescence spectroscopy.